Welcome, everyone. They put me in the 2:30 slot, which is like the 5-hour energy slot if you see any of those commercials. So hopefully you don't fall asleep. But if you do, I'm not offended. But hopefully I got some cool stuff for you today. So my name's Jeremy Lund. I'm a principal engineer at Jane.com. We're a social selling platform for all sorts of independent sellers. Some of the things that are important to me, my wife and my pet dog, Oliver, who really loves my wife way more than me, but he gives me the time of day once in a while. And my kids, which is a gross generalization of the word, as my kids are pretty old. So anyway, if you want to follow me on Twitter, it's at Jeremy_Lund. And I'm going to have the code examples, most importantly, on my GitHub repo right here. It's under my GitHub account, London Callbags UtahJS. That's a 0 between the D and the N on London, so I thought it was cute. Anyway, so getting into callbacks, we need to talk about a few other things first, and just a brief review to just get us all on the same page. The first thing is callbacks. So we've used them, we love them, we loathe them all at the same time. Just briefly, a callback is a function that's used to help manage asynchronous behavior. So usually we use it as something where we call a function to do some kind of asynchronous behavior, and we give it this other function that says, when you're done doing your asynchronous work, invoke me. This is an example from the Node API, the file system API, where we either get back an error when it resolves, or we get back the file content as a buffer. And this is pretty simple. It's pretty basic. It's easy to use. At scale, though, it becomes a little bit harder to work with. This example here, which isn't done very well, I just needed to show multiple callbacks on the page. We have one where we're reading the directory and then presumably want to read each of the files in and do something with them. And the read directory function has a callback, and then each file reading that in has a callback, and pretty soon we have something that's referred to as callback hail, where it usually signified by this flying V pattern and a lot of complicated logic that has both our business logic in it and then also our orchestration of how to handle asynchronous behavior. So that's the definition of a callback. We will come back to callbacks soon because that's part of the crux of my talk. But let's look at streams now, because callbacks, I mentioned in the introductory slide, is a new spec for streams. Let's look at the stream libraries or ways that we have to handle collections of data right now. The first one is just arrays or iterables. These are synchronous pieces of data. Most of the time we've used these array functions, and we have the basic functions that are right off the array prototype that's built into JavaScript. Filter, map, reduce. We also have for each that we can use for side effects. The idea being we can filter pieces of information coming through on this array. We can transform those values using map, and then we can also add them up together or concatenate them or combine them in some way using reduce. An important thing to note with arrays and iterables is they're not asynchronous, they're synchronous. And it's also got this poll interface. The array sits there by itself until we actually run an operation on it. So as soon as we invoke filter, it's eager. It happens right there, and it does that transformation, and it spits a new array out that does that value. So it's eager and it's poll. It doesn't do anything unless we ask it to give us something. So we have a poll interface there. It's important with this. Second one is promises. Promises were built partially to help with some of the callback hail and managing asynchronous behavior in JavaScript. Gives us a new spec. This one here, after 1 second, just resolves with the value of hello. And then we can chain to that promise and get the resolved value and do something with it. In this case, we're just logging it out to the screen. Like the arrays and iterables, it's eager. As soon as we create that promise, it's immediately invoking the promise. So oftentimes you'll defer that by wrapping it in a function or something. Also, it sends a value. Unlike the arrays and iterables, it's pushing a value to you rather than polling. When you create a promise, at some point it's going to send you a value, but you don't necessarily have control of when it's going to resolve. Last but not least, and I gave a talk at this conference a couple of years ago on observables, we have observables. It's kind of a nice marriage between the arrays and iterables and the promises in that it's pushing data to us and it can push multiple values to us over time. So in this case here, we're going to get each value, the 1 through 5, at some period of time after, and we're telling it to do various filters, transforms, and other operations on it. It is also pushing data to us, but unlike the promises and the arrays, it doesn't actually do any of this functionality up here that's in the from or the pipe until we hit subscribe. Subscribe is what activates all that chain to do. So it just sits there dormant until you actually subscribe to it. There is one form of communication that you can tell it you're no longer interested in the data with subscribe, and usually with this subscribe you can get a handle to that function that's an unsubscribe function that you can then call to close it out. But that's the only example that we have with all these examples of actually being able to unsubscribe and say, I'm no longer interested in the data or what you have to say. So just to summarize on this push and pull mechanism, we have arrays and iterables. They have a pull mechanism. We ask data from it, and it gives it to us one at a time if it still has data. Promises, it pushes a single value to us eventually, whether it's an error state or a resolved state, but it's one value. And then we have observables that will push multiple values to us over time. The question could be, why don't we have something that can work with both? Why can't we work with push and pull and do something in a more unified fashion? And that's where Callbacks comes in, this new spec. It was created, the spec was proposed by Andre Staltz. If you've heard his name before, if you've heard of Cycle.js framework, if you've heard of Xstream, if you've heard of RxJS, he's a contributor on that as well. He's made this proposal here, and it's a mechanism to be able to kind of unify both push and pull mechanics on streams. So one of the things he noticed with this, and this was kind of the crux of Callbacks itself, is that our pull mechanism is nothing more than really two pushes. If you think of a pull as I'm asking for data, and then the thing that I'm asking data from says, oh, here's some data, treat it more like a request and a response, then it's basically pushes both ways. I push a request, and it pushes a response to me. Now that we have everything as pushes all the way through, between the consumer and the producer, we can have something that's a unified API between the two, all these different kinds of streams. So let's look at how that works, just the workflow between things. So I have a producer on the left and I have a consumer on the right. This is kind of how a pushable one would work. The consumer invokes the producer with a start message and says, hey, I'm a consumer, by the way, here's a reference to me that you can communicate all your data back on. That consumer effectively is a callback. The producer then sends a message back to the consumer and says, okay, I acknowledge your request, and by the way, here's a talkback, a callback that you can talk back to me on if you need to have a conversation with me. But I've recognized that you want some data from me. Then, in a pushable thing, at some point in time, it's going to then invoke that consumer again with data. It's going to say, here's some data, consumer, and then maybe somewhere down the line again, it's like, here's some more data, send some more along the way. And at some point, either the consumer or the producer, in this case, the consumer's doing it, says, I'm no longer interested in your data, stop. And it sends a message, and the producer will no longer send any more data. Again, that could also happen from the producer side, the producer sending a stop if it has no more data in its queue and needs to inform the consumer. In this case, the consumer's initiating that stop. With a pullable one, it works somewhat similarly. The initial exchange is identical. As a consumer, we send a message to the producer and say, hello, I'm ready for some data. I'm interested in what you have to say. And the producer says, okay, thank you. Here's a talkback that you can communicate to pull data from me. The consumer says, thank you. I will send you now a data request on that talkback message. And a request to the producer, if it has something, it's like, okay, here you go. Here's some data, and I'll send the value back. And then the consumer might go, okay, do you have some more data? I want more data. And it sends some back. And then if it's finished, if the producer has more data, in this example, it can send a message of a stop back to the consumer to say, we're done with our communication, I have no more data for you. So just to summarize this specification between the two, we have kind of three actions or types of actions in the middle here. We have start, data, and stop. The start is to initiate the conversation, both from a consumer I'm subscribing and from a producer I'm acknowledging that subscription. Then if you look at the producer side, he's saying, hey, I have some data for you. The consumer, she's saying, do you have any data for me? So that's the pullable side. You could also, we'll talk about this later, you'll notice in this interface, we have data with a value. There's nothing to say that the consumer can't send data back up to the producer, and we'll actually use that in a demo later. The last one is stop, basically saying, I'm done with the connection on either side. There's one we didn't go over in our examples, and that's you can also send an error to say that it errored out for some reason, either getting the data. You could imagine if you wrapped one of these around, like, say, a fetch call and the network was down, or the fetch resulted in some kind of server error, that you could return this kind of response instead. The API itself actually takes those three words, the three action types, start, stop, and data, and squishes them down into 0, 1, and 2. This freaked me out when I first saw it, because I've worked with languages over the years that used constants for values, and I'm like, oh, magic numbers. But it actually, you get used to it, and it's actually not too bad. So after we talk about what the point is, let me show you some code here. So let's look at a simple example, or actually build something. So let's just take, actually, I'm going to do that. Thank you. I was going to do that before, and I completely forgot. Oh, wow. I like the command plus. I know, I'm just going to do it this way. I like the 20, because I like precision. I like it how I have it. Thanks. All right. So we have our producer that's sending a start message to the consumer. So let's write a producer and consumer that does this. So the consumer, we talked about our contract. It can send it's already sending the 0. It's either going to get back a 1 or a 2, frankly. So let's just do if type equals 1, and let's just say for sake of our, now on a type equals 1, the data is data that you want to work with. So we'll just put a console log, we'll just put value and data, and of course with this, we're not going to get any data yet because we have to have the producer sending something. So the producer, the way the contract goes is when I'm invoked with a 0, then I should be sending something. We first of all know that the consumer or the sync is the data that's being sent, because in a 0, 1, it's always the function. It's the talkback. And then we can say, okay, with this, we can, let's see, we want to send data like, say, every second. So let's see here, set interval, let's say like once a second, we want to send some data down to our sync once a second. So let's save that, and we'll get our, I love this tool, Quokka. It's great. And it's doing something wrong because I have 2 of them running, and I'm going to stop them all, and we'll start this one up again. Okay. And I've got something wrong here, so let me see here. Line 10, thank you. CC data, oh, actually what I need to do is be sending my count, and I need to have a count. So you look at this code over and over again as you build it and redo it, and then forget. Let's restart that again. Okay, so you can see that it's writing out every second. So we have these 2 things connected together, but what, say, we wanted to do is at like some period of time we want to be able to stop this. Say do like a set timeout and be able to, I don't know, like 2.5 seconds or something, terminate this. How will we go about doing it? Well, we know when we get a message of 0, that's our connection, our acknowledgement back from our producer. So we can say with this, let's do, we know that the talkback is coming here, or our callback is the data. And so after 2 seconds, we should be able to call the talkback with a termination message of 2 and have it actually do something. Let's just start this again so I can show you. Now, it's not actually going to work this time because we don't have, see, it's just going to keep going because we aren't actually handling that in our producer. So our producer needs something that actually has this handle here, and we need something that will actually, somewhere in our code, do the clear interval of that handle on a message coming back of termination. So the way we can do that is actually with another callback. So instead of sending, we didn't ever send a sync of 0 message back to the sync. So we're not technically following the spec now, but what we can do is put in here, I'm going to reorder some stuff in a minute. We could just say that callback that we send back to the sync, hey, this is something you're going to talk to me on, and if you sent me a 2 or a termination, then I'm going to clear this interval. So let me just reorder a couple things here really quick, and this will work. So we're going to put, when you get a message, I'm going to clear that interval. Now, of course, I need to move a few of these things up above. So now when we do that message, we get the acknowledgement back, and the consumer gets a handle or a talkback that it can communicate with. And you can see it only did the 2 messages out. Let me just run that again. 1 and 2. Now, you might be thinking, holy smokes, Jeremy, you've got to write all this stuff out every time you do one of these. What a pain. The point is this is a very simple spec. And so doing this, you can build a lot of smaller operators and atoms to build larger stream management facilities. Just looking at some of the examples that we have out here, this is what you end up doing 90% of the time. This is a library called Callback Basics, which has a collection of a few of the operators, 13 of the most common ones. You end up importing the types of operators and then piping them together to do the actions. So this one here, if I run it, you can see that once a second, it's going to filter out even numbers, or it's going to include even numbers, multiply them by 3, and then write those ones out. And it's going to keep working on that. This is more or less what the code looks like. I just want to show how easy it is to actually write an operator to do some of the behavior on here. Let me just stop all of those. Let's go back to the slide. So you might be thinking, what's the point of all this? We have RxJS, we have promises, we have arrays. Why do we need this? There's a couple of reasons why I think this is really useful. First of all, the ability to do both push and pull mechanisms on stuff is really, in my opinion, valuable. You can write the same type of operator and use it on both types of streams of data. In fact, the map and filter that I was showing just in that callback basic stuff, those are written to both work with push and pull mechanics. Adoption is really nice as well. We adopted our dog. That's why I put adoption dogs on there. Oliver's awesome. I wish I could have brought him, but you know. We had a project at work where it's already using a lot of libraries, Redux Saga, Redux, React, Lodash, it has a lot of different libraries in it already. And the idea of bringing Rx in was just not something that was very viable for the team. They didn't like that. But I needed something that was observable-like behavior that I needed to be able to include in my application. It just was the right solution, right tool for the job. Using a few, these operators are like 5 lines long. Look at the map operator, I think it's 3 or 4 lines long is all. Just bringing a handful of those operators in along with a custom one that I needed to write for my code that was about 15 or 20 lines long, bringing that in, I was able to get the observable behavior that I needed, but not bring in all of Rx. And I know you can do tree shaking and all that on it, but this is a little bit easier way to bring a few lines of code into your code base rather than bringing in a whole library. So I really like it in terms of adoption. The size as well is important. It is just a few operators. It is a specification. So you can write your own if you need to. But there are like over 120 operators already written out there by different people that meet the spec and you can plug in. Another thing that I really like about Callbags is Geysers. Well, geysers help illustrate it. So this picture here is one I took at Yellowstone National Park a couple of months ago. This is Riverside Geyser. This thing goes off about every 5 to 7 hours. Goes off for roughly 20 minutes at a time. And of course, like many geysers in Geyser Basin at Yellowstone, it's based on projections. There's ones like Riverside's actually pretty easy to predict. Old Faithful, of course, is very easy to predict. But they are predictions. They don't always go off at the same time. Meanwhile, this is another geyser here. Now this geyser here, I don't know if any of you have seen this before. It's Soda Springs Geyser. It's in Soda Springs, Idaho. Came across it in the same trip. This one erupts every hour on the hour, and it's about 2 to 3 minutes long, and it's controlled through a cap. So legend has it, or not legend, it's actually the true story. They were trying to drill down into some of the hot springs water there in Soda Springs to start some baths and some other things that they wanted to do. When they drilled down and pulled it out, and it started erupting into the air, like 70 feet in the air, for days and days. And apparently, this was like the 1930s, the Secretary of the Interior called Soda Springs and told them to cap it because it was impacting Old Faithful's eruption schedule. So there's a lot of calderas there in Wyoming and Idaho and Montana that are kind of tied together. So they had to cap it, but they've come up with a compromise, and that's, we will let you turn on the geyser for 1 hour a day, which was nice because we could just stand there, and at 8 p.m. I could just stand there with my video camera and just take pictures, or with my phone. I don't have a video camera, but anyway. This is like callbacks. Usually with streams, there's not this mechanism to be able to communicate back and say, could you shape the stream a little bit differently right now and send messages back up? The only thing you have is with observables, you can do a unsubscribe or a cancel. But what if we could send messages back up? That's something that's kind of an interesting idea, because normally with like observables, you send stuff back down the top and it goes back through the chain. What if we could send stuff back up? So let's look at a demo between these two, and I keep going backwards. So let's go to this demo here. So this is dog photos from the Dog CEO API. If you're looking for a fun demo API, dogs.ceo is great. Random dog pictures. So we have a picture here of a dog, and I've got the library running, and then every 10 seconds, it should be making a change. Okay, let's reload this. Oh, it is changing it. Okay, so let's take a look at the code here for this. So every 10 seconds, it's rotating through, right now, Akita pictures. And I have a drop down here, and we'll look at that in a minute, but let's just look at how this works. We've got a source here in our React code. Let's actually look at it from here, where we're setting up every 10 seconds, we want to have a stream that goes and fetches dog pictures. And this stream, we're subscribing to it right here. And we say if we subscribe, we know we have the function, we have the talk back from our source. We want to hang on to that, because when we unmount our component, we want to be able to unsubscribe from it. And if we have a one message from it, that's we have data, and we're like, oh, this is sending us a stream of dog URLs, of dog image URLs. So we can set the state of our image, and that's what's being referenced down here for the picture, is that state variable. What's cool about this is we want this drop down to be able to also work. So when we click on these, we want to be able to send up. Now, traditionally with observables, you would send additional data back down the stream. You would say, okay, I've changed this to, let's say, pug, or Yorkshire Terrier here. And normally you'd send stuff down the stream and it would do a new fetch. But I thought, let's try this a little bit differently, because this is callbacks and it's different. So this is my fetch. It's just my simple fetch getting the value. But the callback here, it has a little trick in it. The value that we send back, this is the talkback right here that we are sending back to our sync, that it can interact with us. It's API. So if it's a 0, we just ignore it. It shouldn't be sending additional subscribe messages to us. Anyway, if it's a 1, we're saying you're requesting a data. It's like a pollable interface, but it's sending additional data with it. What we happen to send is the new breed. So we say, okay, when we get a new breed, let's go do a fetch again with that new breed and set the value so we have that current breed available. And then let's just send a new value down the stream. of that new value. And then we can also unsubscribe using that talkback as well. Normally with the stream, just with the push interface, it would just fetch the breeds every 10 seconds and then send one down. This allows us to switch that breed, and it actually doesn't store anywhere else. Thank you. It doesn't store anywhere else except for in the callback stream. So let's see if this works. So pugs. And we have a pug, cute little pug, sending up. It's pretty simple, and I don't know, is anybody, I'm partial to Yorkshire Terriers. They're the closest to my dog, which is a Yorkie Poodle mix or a Yorkie Poo. So we get some Yorkies there, and it's sending it through, and every 10 seconds works, and sending it up. How about that? It's a little bit different than doing it just with a regular observable there. I think it's pretty cool. So let's see here. Going back to some of the stuff I have here. So one of the quotes from Andre Staltz, who wrote the Callbags spec, is he doesn't think Callbags replaces RxJS, Extreme, and these other libraries. So he doesn't view it as a replacement. If you start looking at these callback operators, it's kind of a more foundational piece. In fact, as a proof of concept, he wrote an API analogous to RxJS on top of callbacks. So he used that as kind of the foundational piece and built his own API on top of it just to see that it could be done. But these operators, they're performant, they're light, they're fast. For small projects, I think that they work fantastic. If you're looking for additional information of where you can find out more about callbacks, there's the callback wiki and the spec. If you go to this GitHub repo, GitHub callbag, you will not find a line of code there. It's the specification for what I went over earlier, how these things communicate. The wiki on there has a listing of all the different operators. If you are translating something or needing something maybe, and you've looked at RxJS for something, or Extreme, or Most, or one of these other stream libraries, chances are you're going to find the operator, source, or sync that you need in that list. Somebody's already built it. But you can always build your own, which is fun. The premise for why you need callbacks is written on Andre Staltz's blog, and there's also an introduction by Krawallar. There was also, I was going to point out, there's a couple of websites. Let me just show you here. So that's the callback wiki. Just look at the number of operators we have here already organized. And these are not just written by Andre Staltz. I think he's written probably 20 to 30 of them, but there's over 120 here. These are written by, in fact, I venture to say that there's at least one person here in the audience who has written one of these, besides me. I'm not in the audience. So we have those operators. The only challenge I will say with callbacks, so this is Callbacks Basics, which I was talking about earlier. It has a handful of the operators just built into it. Let me find the listing here. Common ones that you would use in a lot of different projects. The only downside of callbacks is sometimes it's a little hard to find all the operators that you need because you got to kind of pick and choose what you want, and that can be a little tedious, honestly. But beyond that, I've had a lot of fun working with it. I found it tremendously useful. And they're really easy to test too, because that spec is just lined up nicely. So anyway, I know break's coming up, so I'm going to let you guys go a few minutes early. If you have any feedback for me, please direct message me on Twitter. You can find my handle right there. Please just send me a direct message. Let me know what you liked, what you didn't like, if you want to learn more about callbacks. And feel free to check out the repository. And during the break, feel free to come find me and talk to me. We've got a half an hour break. I'd love to talk to you and get to know you guys. So anyway, thank you. Thank you for coming.